Yes, good afternoon, student. We are here in the something engineering chronicles, which talks everything about the engineering. One of the engineering part is something about the machining. And under machining, we have so many operations, so many machines. So one of the commonly frequently used machining operation is turning. Let's talk something about the turning. And one of the key part when we do any machining operation is the time calculation. Variety of aspects of engineering is very much necessary to understand how much time a particular operation will take to finish the component. So various aspects of importance of machine time calculation we may discuss going ahead in upcoming videos. But now let's see how we can calculate the time required for turning operation under given certain cutting conditions. Certain conditions. So we have certain conditions like a cylindrical rod, initial rod of a 120 mm diameter and 280 mm length, which is to be turned down to final diameter of 70 mm over length 120 mm. They have given certain cutting parameters like cutting speed is 55 meter per minute, feed 70 mm per minute, depth of cut to be kept as a 0.5 mm, and approach length 12 mm. What is that approach length to consider? I'll tell you going ahead. Now we have to calculate the time initially for a single component, and then they are asking calculate the total time required for entire component, that is 12,000 component. Let's see how to go ahead. Right? Now this is what the initial diameter of the workpiece which is given to us and length of the component. Now we have to do the turning operation and convert this into this particular shape. Reduce the diameter to 70 mm and length by 120 mm. So whenever we think about the machining time calculation, the most important part is that what is the total length of tool travel? So my tool from starting point till it completes the entire product, how much length the tool has traveled. So here let's first calculate the total length of tool travel. Then if we divide that by the given feed rate at which tool moves, will give us the total time calculation, something like this. So let's first calculate the total length of tool travel. Now here what we see, how much maximum depth of cut is allowed to take 0.5 mm. So means when I take 0.5 mm depth of cut, like here, if I take it, the cutting length as 120 mm, one cut gets over. So when I'm completing the one cut, total reduction in the diameter is how much? By 1 mm. We can think 0.5 from lower, 0.5 from here, right? So after finishing one cut of a length 120 mm, my total diameter reduction is 1 mm. So now the remaining diameter is 119. So likewise, I have to convert from now from 119 to 70. So if how many cuts I have to take? In one cut, 1 mm diameter is getting reduced. So total 50 mm diameter is to be reduced. So I have to take a total 50 cuts. What is the length of one cut? 120 mm. So simply we have to multiply 120 mm length of cut into number of cut, that is 6000 mm is the tool travel length. Now we have to assume something called approach distance, because tool at the start can never be in touch with the contact all the time. The tool is little away from the workpiece, right? The tool has to travel certain distance in view of touching the workpiece and then start the cutting. So something like you can say, so we assume maybe 10 mm, 12 mm, 15 mm. It may vary a little. See, this is the chuck workpiece is somewhere here. So tool can never be at the touching point on the workpiece. It is little away from the workpiece. So this particular distance is called as approach distance. So you can assume it equal to 10, 20, 50 mm is okay. So what we got, the total length of tool travel is 6000 plus 10, 12, whatever it is. Then let's go down feed rate. Feed into speed. Let's go ahead and calculate. What is given? Feed is given already, very good. 70 mm per minute. And the RPM of spindle is not given. We have to calculate. How to calculate? What has been provided is cutting speed. How much it is? Sorry, this 55, not 70. This 55, right? So 55 is the cutting speed. Now what we know, the cutting speed formula, pi dn, pi into diameter of the workpiece into speed. So here we have the diameter of the workpiece, we have the cutting speed, and that is RPM can be calculated. So now there is confusion, which diameter to consider. Shall we take 120 or should we take 70? What is to be done? Because after each cut, we are taking total 50 cuts. After each cut, what is happening? Diameter is getting reduced. So neither we can select 120, which is initial, neither nor we can select the 70, which is last diameter. What is to be done? Take the average of these two, initial diameter, after diameter, take the average of that and consider as a diameter of the workpiece during calculation. What we can see, initial diameter minus after diameter upon 2, and we'll get 120 plus 70 somewhere around 95, right? So let's calculate 70 pi. So we got here. Now this was the formula, but there is something missing. What is that missing part? See, the unit of cutting speed is in meter per minute, meter, whereas the diameter is in mm. Will not work. So just convert either of one thing and make left hand side equal to right hand side. So just to convert this diameter which is in mm into meter, what I'm going to do, divided it by 1000, so that now we have the left hand side equal to right hand side, and we can easily now calculate the spindle RPM. Done? Okay. Now spindle RPM is okay. Done. Now again, let's what remains. Everything is there with us. Now let's see the unit of feed, mm per minute, whereas speed is we have revolution per minute. So something is missing. So do one thing. Feed which is given 70 per minute, just convert that into per revolution by dividing it by the spindle RPM. So we got the feed. Now we have everything with us. Take the formula, put the values. What we got here, total machining time required for one component. Right? This is very much important to convert the feed. Now this is for one component, but what is the actual question? Calculate the total time for 12,000 component. Simply multiply 12,000 by single machining time. Just do it. This is per component, right? So for 1200 components, 86 into 12,000, sorry, 12,000 components. So we got the answer, maybe in minute or maybe in hours. So this is how to look into the machining time calculation for turning operation under given certain conditions, dimension conditions, some cutting parameters. So going ahead, we will see some other machining operations as well, where we see that how to calculate the machining time, because as we are changing from one operation to another operation, certain assumptions, tool will change, machine will change, some cutting parameters will change, some units will change. So as we move from one operation to another operation, slight modifications are there in terms of machining time calculation. So what are those different slight changes? And how to see for the machining time calculation, maybe for milling, grinding, drilling, we will see going ahead as we go ahead with the different videos, right? So currently we are in the module of machining time calculation for a variety of machining operations. So stay tuned. Soon we'll meet to discuss something about the next machining operation and time calculation. Okay? So let's stop.